Alright, so here we go with our review, or the solutions to the homework. And what I'd really like for you guys to do is to count up the number that you didn't do and put that at the top and be honest about it, and then correct this and learn this if you can. Of course, this is a recording. You can find this on YouTube, or if you've joined the iTunes University course, it's posted there also, and you can rewatch this as often as you want. Alright, so this first problem is a tension problem. These are two ropes, T2 going off to the right and up, and T1 going off to the left and up. There's a 7 kilogram mass hanging from it, and we're going to work this problem just like we work every other problem. We're going to resolve the two vectors into their x and y components. So here's the x for T1, that's this one. T1 times cosine of 25 is equal to that, 0.906 T1. T1y is the sine part, so sine of 25 times T1 is this, 4.423. T2, we'll break it up into x and y. This time the angle is 65. Cosine of 65 times T2 is equal to this, 0.423 T2. Sine of 65 is the y portion, that's the opposite. So T2 times sine of 65 is 0.906 T2. Alright, so next step is to sum our forces in the x. I'm going to do this. I've got negative T1x, and I picked negative because it is going to the left. Plus T2x is equal to 0. T1x equals T2x. If I rearrange this and move this T1 over. And so now let's sum forces in the y. Both of these are pointing up, so they're both going to be positive. So T1y plus T2y minus 7 equals 0. This actually should be 7d because it is times 10 times gravity. And taking my sum of forces in the x equation, I get 0.906 T1 is equal to 0.423 T2, and I got those from here. T1x, T2x, and now I'm going to solve for T1, and I get 0.467 T2. So that's a relationship. Sum of forces in the y direction, that's 0.423 T1, which is right here, and that's going to be plus 0.906 T2 minus 70 equals 0. I'm going to take this relationship that I created right here, and I'm going to plug it in for T1. So I get 0.423 times 0.467 T2 plus 0.906 T2 minus 70. I add up my terms with T2 in them. I move 70 over, and I get T2 is equal to 63.43. Then I take this relationship again, plug in T2, and I get 29.62 newtons. Alright, next question. Number 2. This is an inclined plane problem. I draw my free body diagram. I've got my force of gravity going straight down. I create my axes like this. I've got x going down the plane and y going off the plane. And then I have the normal force pointing upwards. Friction is pointing to the left because it's always opposite of motion. Again, friction force is mu times normal. And I'm going to break my gravity up because it's the only force not in one of my axes, the principal direction. And so force of gravity in the x direction is 500 times sine of 30 because I'm talking about this little portion right here, which is opposite of that angle. And that equals 250. Force of gravity in the y direction is cosine of 30, so 433.03. Sum of forces in the y direction, normal minus force of gravity in the y. Those are my only forces in the y. So normal is actually equal to the force of gravity in the y, which is 433.03 newtons. Sum of forces in the x direction, and the unbalanced force, they just want, when I add up all my forces, what do they equal? So sum of forces in the x direction is going to be force of gravity in the x. It's positive because it's pointing downward, and minus the force of friction because it's pointing up the incline. So this is 250, which I got from right here, minus mu times normal, which is 0.05 times 433.03. My unbalanced force is 228.35 newtons. All right, number 3. A 100-kilogram block at rest on a 45-degree incline. The coefficient of friction between the block and the incline is 0.10. The acceleration of the block is equal to the net force divided by the mass of the block, which is basically Newton's second law that we've been working with. How fast will the block be traveling after 2 seconds? Free body diagram. Looks very similar to what we had last time. Again, my coordinate system, I picked down the incline as positive. Summing of the forces in the y direction, normal, pointing upward, minus the force of gravity times cosine of theta, which is that component, and I get 700. When I rearrange everything, move this portion over, force of gravity times cosine over to this side, I get 100 times 10 times cosine of 45, which is 707.1 newtons. Sum of forces in the x direction. The component of gravity in the x direction is this, minus the force of friction equals mass times acceleration. Plugging in what I know, 100 times 10 times sine of 45, minus 0.1 times normal force, which is 707.1, because again, friction is equal to mu times my normal force. That equals 100 times A. It's going down the incline, so this is positive also. When I solve for all of this, I get 6.36 meters per second squared for acceleration. Next thing I do is I have to use my kinematic equations. I'm going to use this one to find out my final velocity for how fast it will be going. Initial velocity is 0. So VF is equal to V naught plus AT, 6.36 times 2. It's 12.72 meters per second. That's my final velocity. Number 4. A block is on a 20-degree incline, and it has a rope attached to a spring at the top of the incline, which has a spring constant of 65 newtons per meter. If the spring is stretched 1.3 meters, that's x, and the acceleration of the block is 0.35 meters per second squared up the incline, what is the mass of the block? So here's my free body. Again, I say down the incline is positive. So this is moving upward, so I've got the spring which is stretched and it's pulling the block that direction. Normal force is up. Friction is opposition of motion, and then I have my force of gravity again. So sum of forces in the y. Oh, just to remind you, the spring, the force of a spring, I'll write this down here, is equal to negative k times x. And there's a negative here because the force is always opposite of the direction of the stretch. All right, what I typically do is I just multiply k times x, and then I base the positive and negative on my free body diagram. So you'll see what I'm talking about in a second. Normal force, for sum of forces in the y, is normal minus the force of gravity in the y direction, so that component. That's normal minus Fg cos 20. If I go down here, I get normal is equal to mass times 10 times cosine of 20. This is my force of gravity, mass times 10. I get 9.4 meters. Or I'm sorry, 9.4 m, which is kilograms. All right. Sum of forces in the x direction. Force of friction pointing down the inclined plane. Force of the spring is pointing up the inclined plane, so he gets a negative, and that's equal to negative m times a. Negative because the block is moving up the incline. So now that I know normal, I can find my force of friction. So this is the sum of forces in the x direction. 0.001, which is mu, times 9.4 m minus 65 times 0.13, and this is equal to acceleration, which is negative 0.35 times m, which is the mass. So let's clean this up a little bit. I'm going to move this over to here, so I'm going to get 0.001 times 9.4, and that's 0.0094 m plus 0.35 m is equal to 65 times 1.3, and that's 84.5. All right, combine these. So 0.35 plus 0.0094, and I get 0.3594 m is equal to 84.5, and divide 84.5 by 0.3594, and I get m is equal to 235.11 kilograms. All right, number 5 I told you to skip. Number 6, find the distance this 20 kilogram lawnmower has traveled in 3 seconds if the force applied is 400 newtons at an angle of 30 degrees below the horizontal, and the coefficient of friction is 0.2. So, free body diagram: normal pointing upwards, gravity pointing downwards, force of friction pointing to the left, and then this applied force is down and 30 degrees. 400 newtons. So, summing of the forces in the y direction: normal minus the force of gravity minus 400 sine 30 equals 0. Sum of forces in the x direction: 400 cos 30, so that's the portion of that going that direction. Cosine 400 times cosine of 30 minus 0.2 times the normal, that's your friction, and that equals MA. Normal, if I were solve for n, I get normal is equal to 20 times 10 plus 400 sine 30, which comes out to 400 newtons. And then I'm going to use that with my friction, so 400 cosine 30 minus 0.2 times 400 is equal to 20 times A. So this is my force of friction. This is my applied force in the x direction. When I do all the math, divide by 20, I get 13.32 meters per second squared. I'm going to use this x is equal to x naught plus v naught t plus 1/2 at squared to find my distance, where x naught is 0, v naught is 0, so I end up with just x is equal to 1/2 at squared. 1/2 times a, which was 13.32, times 3 squared was 59.94. If you have questions about this, you can watch the video again, or the next time we're in class, you can ask me about it.